kid, actually.
And the other one. That's good.
This is my project about the geometry of music, and I sort of researched the way the different pitches of the chromatic scale relate to each other. The first chart I drew is called a harmonosphere, which is, it's like a clock, but it's with where each hour would be. Instead you have the notes of the musical scale. And each line on this connects all the possible intervals that you can create between all the notes. So you get this really cool geometric design with all sorts of angles and shapes, quadrilateral triangles, hexagons, fun stuff. And what you have on all these red lines are going from the tonic, showing all of the basic intervals, which is also the red lines all mirror each other. So like major second, major seventh, that would be these two. They have the same angle from the mirror, which is the diminished fifth, and so you have that same thing applying to everything. The diminished fifth is its own mirror, so that's why it is the line of symmetry. The second chart is displaying the results of Pythagoras' research about geometry and music and physics and all that sort of really simple stuff. And it's showing about how if you, like on a guitar string, such as this, if whatever pitch it is, the octave, the pitch that is one higher up is produced by pressing exactly halfway on the string, and the same thing for each one, depending on like 4/5 to produce the third, 3/4 to produce the fourth, 2/3 to produce the fifth. And what the circles are, which it might be hard to see since it's in light pencil, is each tone of the scale in the circle of fifths is rooted in a circle that is rooted in the center line of the circle before. So the circle for, bless you,
Thank you.
for E is the largest one, and then the circle for B, which is the next tone in the scale fits up, is rooted, or the middle, the intersection of the circle is the middle of E, and then the intersection of the next smallest circle
Small circle.
smallest circle.
The intersection is at the diagonal.
No, it's at the vesica pice, or the vesica. There's some fancy geometric term that I forgot. But it's the center line of the circle, like the exact straight up rate diameter of the circle. If that makes sense.
It does.
And so what I did to kind of practically demonstrate this was I invented a musical instrument which I call a unitar, because it's a guitar with one string.
Not unitard.
Not unitard, unitar. And what you do is, right now it plays an F sharp. Now it does. And so if you want to produce an F sharp one octave up, you put the fretboard about there and pluck. So that's one octave, and that's half the length of the string, so. Yeah, whatever. And so you can do the same thing with each one. So like about here, about 3/5 of the string would be producing the major third.
Cool.
Yep.
Now play Mary Had a Little Lamb. Using those three notes.
This is painful.
What is that? It's really just a unibase. Unibase. Look at he's playing like it. I look like a guitar.
This is quite painful.
Hey, he's got it.